Let's try the next example here. Determine where the following function is increasing and decreasing. We have a nice polynomial here. We typed it into Desmos, and we can see it's a nice purple graph. It looks like it's decreasing and increasing here, up and down. And to talk about increasing or decreasing, we need to really focus on the maximum or the minimum, or even these points of inflections. We need to focus on where the derivative is 0. So the idea of derivative being 0, we find the derivative. We're going to use power rule here. We're going to drop the 5 down. 5 times 27 is going to be 135. T to the 4, you go down an exponent using power rule. And we repeat the same all the way across. Then you look at this nice polynomial and you factor out the 15t squared. And we have a nice trinomial here, which we might try to factor, but sometimes trinomials do not factor, in which we use the quadratic formula here. You remember that song? X equals minus b plus minus square root b squared minus 4ac all over 2 times a. So you can see here that Professor Paul, instead of using x's, is using t. So when we look at this first part here, this first factor, 15t squared, when t is 0, something times something becomes 0. That's the slope is 0. That's what we're interested in. We're going to call that a critical point. When t is 0, you can see this nice line at the bottom here. We have a nice dashed line going up and down. I'm going to call this a border, a country border. So think of, to the left is Canada, to the right is USA. We have nice borders set up. But another critical point in which we have to set up the borders is going to be also where we have 2 more solutions by finding the roots or the x-intercepts by using quadratic formula. And we simplify here. We can convert the entire radical to mixed radical. As a fair Texas judge, we can divide top and bottom by 6. 12 divided by 6 is 2. This part here divided by 6, the 6 cancel, becomes root 30. 18 divided by 6 becomes a 3. So we have 2 possible answers, either the positive version or negative version here. And so when we say negative 1.1-ish or 2.5-ish, you can see that we have another country border set up here and here. So how many countries do we have? We have, to the left here is 1 country, 2 country, 3 countries, and 4 countries in total. And the key here to focusing on whether the function is increasing or decreasing is to plug in a test point. Okay, so to illustrate the countries, I put in some nice orangey border walls. We punched in these critical values of negative 1.159, 0, and 2.492 here. And to the left of the country, to the left of this nice maximum here, we're going uphill. So definitely we're talking about the function being increasing from left to right. Now, between these 2 countries here, we see it's definitely decreasing. So all you have to do is plug in some critical point, plug in some value, some x value or some t value that's within the interval, and just pick a nice number. And the value between where my mouse is shaking here that Professor Paul chose was negative 1. Negative 1 is a nice number, and we're focusing on the derivative. A prime of negative 1, the derivative is negative. So who cares the fact that the answer is negative 75? But the fact that it's negative, it's less than 0, means that the graph is decreasing, in which the purple graph is. From left to right, in fact, it is decreasing. And another important thing to remember is that just because the derivative is 0 does not mean that it's a maximum or minimum. It could be a point of inflection. So here, this is neither a maximum nor a minimum. But plugging in some more points here, we have the a prime of 1 is a negative, which means downhill, in which this graph is going downhill. And finally, over here, plugging in a nice test point of 3, the derivative, a prime of 3, is 2,565, which is definitely uphill. And you can see it's quite steep. It's uphill. So using this information, setting up country border walls of critical points, you can kind of get a rough shape of what the graph looks like. So when we have a prime of -2 is 2040, we know it's positive, so we can draw like a little stickman drawing. It's uphill. And here we have a prime of -1 is -75. We can roughly say it's downhill, and then roughly say it's downhill again, and roughly say it's uphill. And when we have this slope, the derivative going up and down, and we have this nice tent type shape, we know that this is going to be a maximum. And we have a shape going down and up, we know this is going to be a minimum. But what happened here, this here is neither a maximum nor minimum, and what's happening here is going downhill, and you're going downhill again. This happened to be a point of inflection, so just be careful about that one.